Yeah, good afternoon, everyone, Nana. Yes, yes. Good afternoon. In the previous class, I think I explained about some part of energy, potential energy. Am I right? Yes, yes. If you consider the center of mass, how to calculate the potential energy? Right. Good. I don't know whether you remembered the concept or not. Okay, so if I give one example here, suppose what I'm saying here on a horizontal surface, like, sorry, this is one block placed, okay. Likewise, identical blocks here of same size, same mass. Suppose n blocks are placed here. Likewise, how many we draw? Just consider. Likewise, n blocks are placed. Okay. So that thing I'm going to here write in words what n number of identical cubical blocks, each of side length, each of side of length L uh, are placed on a surface as shown. Okay, dimensions are given. Keep in mind. Means each side length is L. Any side, not a cube. Why? Because sorry, here all are cubical blocks. That's why any side of length is L. Okay. Now the question is, when they are piled up, means placed one above the other. Okay. Likewise, piled up. Find the work done in placing them one above the other. Them one above the other. Okay. Means he is trying to place, this is first block, Nana. The second block, he moved to here, placed above it. The third block, placed here above it. And the fourth block is placed to it here, like one above the other, he is trying to pile up. Okay. Like if you place all the n blocks here, okay, one above the other vertically, what is the total amount of work done? He is asking. Okay, first you understood this question, Nana? Okay, later we will try to solve. First you understood the question or not? So shall I write erase this part? Yeah, understood. So I am going to erase here. All right, good. And now move back to here the solution. How to solve it? Okay. Here, first thing, logically, you try to understand This is the surface, and it is the first block. Okay. First block is already on the floor. Okay. Is already on the floor means no need to move it. Okay. So first block is on the floor. Here we are not moving this block. We started placing the other blocks above the first, above the second, above the third, above the fourth, and so on. Piled up. Okay. So on first block, keep in mind, you did not do any work. It is already placed on the floor. That's why, shall I write here while writing the solution? Work done in placing the first block on the floor equals to, I say 0. Why? Because you are not moving. It is already placed on the floor. That's why you did not do any work on the first block. Then on whom I did the work, sir? Yes, second block is there. This one you try to place over it. Oh, I started doing the work in moving the other n-1 blocks except the first block. Okay, first block is already on the floor. So rest of the blocks I'm placing, piling up. Means total out of n blocks. On first blocks you are not, on first block you are not doing any work, means you are doing on the work on whom? On the total n blocks are n-1 blocks. Which is correct, Nana? N or n? N-1. Very good, very good. So you are doing the work on n remaining n-1 blocks. Correct. But look at second block, okay, is there on the floor here, and you are trying to move it to place over the first. Okay, you are trying to move it to place over the first. Okay, observe here, Nana. When it is on the floor, who the second block, this is the second one, and you are trying to move it to place on the first, like this, from here to there. Okay, while moving, if you consider now the dimensions of the cube, side length L, so here the length of this side is L. If you consider the height of the second block as L, then mass is distributed to the total volume. That's why, again, it is the time to consider the center of mass. Center of mass usually will be at the center of the cube. That's why the height of center of mass above the reference level, okay, at a height of h is equals to L by 2. Okay, when it is moved to here, the center of mass came to what height from the reference level? Observe, till to there, it is L plus center of mass came to here, means this is L by 2. Altogether L plus L by 2. Right, correct. Okay, so you changed the potential energy of the second block from L by 2 to L plus L by 2. Changed the potential energy means straight away here I write, try to understand. Okay, I'm going to write here what's the work done on. Here I'm writing work done on the second block is equals to, I write here, work done means change in potential energy. Final potential energy minus initial potential energy. I think you know it already, I told this formula. Final potential energy is formula mgh. H is L plus L by 2. Okay, this is final potential energy minus initial potential energy here is mgl by 2. All of you understood these steps, Nana, what I wrote here? Okay, while calculating the work done on second block? Yes, good. So subtract here, Nana. You can understand mg into L by 2, mg L by 2 get cancelled this part. So you will get that is equals to mgl. Is it right? Ah, right, good. This is the work done on second block. Keep in mind. This is W2. Better I write here. This is W1. Work done on the first block. Work done on the second block. Okay. Now, if I say the third block, you can catch one logical point here. Okay. I think there you can say very easily. So observe here, I am going to write work done on the third block. Yes. Simple Lakshmi Gayatri, second block is placed here. Means initially it has some potential energy based on center of mass concept. Potential energy means mgh. H is L by 2. So mg into L by 2 is the initial potential energy. It is shifted to there, where, over the first block. Okay, the second block is moved to here, from there to here, means the center of mass comes to here. Okay, center of mass comes to here means raised to what height? This height from the reference level is till here L plus L by 2. Very good, Ishan, you are right. Okay, that is 3L by 2. That only I wrote here. Mg into L plus L by 2 you added. I did not add. That's it. This is 3L by 2 minus it is mgl by 2. Subtract. You will get a 2 mgl by 2 after subtracting, which is mgl. What is the wrong in it, Lakshmi Gayatri? Understood? Or else good, good, good. Few students already wrote their work done on third block also. Very good, good response. So here, third block actually is here on the floor. Okay. And its initial height is also equals to initial height L by 2. Okay. But it is shifted. This is the third one. Shifted to here. Shifted to here means to what height? Observe. When I place the third block here, when it is piled up. Yeah, correct, 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 correct. This time you caught the point. Exactly. Center of mass comes to here, right? Correct. This is the third one. Okay. Center of mass comes to here means L plus L plus L by 2. Yes, what is your doubt, Shodasi? This is L plus L plus L by 2. Yes, you have to respond. Shodasi. Yeah, correct, Lakshmi Gayatri. Your answer is correct. Okay. I'm going to write here the third one. W3 is equals to, again, final potential energy minus initial potential energy. Final mgh. H is L plus L plus L by 2. That is third only, Nana. Third block is initially placed on the floor. This is the third block. Third block initially placed on the floor means initially it has some potential energy. That initial potential energy is U1. U1 is, I'm going to write here, mg into L by 2. This is the initial potential energy of third block. It is moved to there. Moved to there means to what height the center of mass you shifted? That is L plus L plus this part is L by 2. So L plus L plus L by 2 is nothing but this is 5L by 2. That I am going to write here. mgh. H is 5L by 2 minus initial potential energy is mgl by 2. Okay. Still, do you have any doubt? Maybe Nana. Yeah, in that way only you will get the answer, like arithmetic progression. Yeah, right. So here, if I take this will be after subtracting Nana, you will get mg into 5L by 2 minus L by 2 is 4L by 2. 4L by 2 is nothing but if you cancel 2 mgl. That straight away I write here. Okay, like this is equals to 2 mgl. I think you can understand. Why? Because it is simple subtraction. That is 2 mgl. So I think now you can catch one point here. Observe W1, I got 0. W2, I got mgl. W3, I got 2 mgl. They are appeared like 0 mgl, 1 mgl, 2 mgl. Likewise, I am getting so on. W1 means 1 less I'm getting. W1 means I got 0. W2 means I got 1. W3 means I got 2. Likewise, work done on nth block, last block, is equals to n minus 1 into mgl. Is it right, Nana? Okay. That's why. Yeah, correct. That's why the total work done means we have to add all the works here. That implies total work done on piling them. Okay, yes, good. On piling them equals to W1 plus W2 plus W3 plus so on. I have to write. In all, straight away in W1, this is 0. In W2, this is 1 mgl. So 0 plus mgl plus 2 mgl plus so on plus n minus 1 into mgl. So if I take this is equals to mgl common, I will get arithmetic progression. 1 plus 2 plus 1 plus algebraic sum of n minus 1 numbers. Okay. N minus 1 numbers. You know, what is the formula for n minus, for n numbers, Nana, sum of n numbers? Sum of n numbers of 1 plus 2 plus 1 plus n equals to what is the formula? N into n minus 1 by 2. Remember? Yeah, good. That formula I'm writing for n minus 1. That implies a sum of 1 plus 2 plus 1 here instead of n minus 1 if I write, that equals to, in place of n I write n minus 1 into n minus 1 is n minus 2 by 2. So is it correct, Nana, sum of n minus 1 numbers? Any mistake I wrote here? So shall I continue? Right. Therefore, the total work done. Yes, continue. Thank you. Total work done is equals to MGL into this part sum what I have here n minus 1 members. This sum is equals to I got here n minus 1 into n minus 2 by 2. Okay, this is the final answer now. That's all. Finally, we got the answer for it. Again, in this problem also, we used the concept of center of mass. Okay, now are you able to follow the center of mass concept, Nana? Okay, will you try such type of model, center of mass concept? Yeah, right, good. Related to potential energy. Good. Last but not least, one small question here. If you say the answer for this question, I will stop this type of model, center of mass concept, and I will move to some other model. Okay, and this type of model considering the center of mass at geometric center is very important model for us. Okay, now what I am saying here, a person, okay, pulls a bucket of water from a well. Okay, for this procedure what he is doing, okay, the minimum length of rope required is say like 10 meters, and mass of rope is say 2 k 0.5 kg per meter. For every meter, the mass is 0.5 kg. Means I think you understood one point here. What is the mass of rope? What will be the mass of rope first, Nana? From the information what you understood, total length is 10 meters. So what will be the mass of the rope? Yeah, exactly, Lakshmi Gayatri. That is 5 kg. Right. 0.5 into 10, that is 5 kg. Good. And he is saying mass of bucket along with the water. Along with the water means full bucket of water, including the mass of bucket along with the water is say some 2 kg. Okay, find the work done to pull it, to pull the bucket to the surface. Sorry, surface. This is the question. Okay, so you have to understand on whom we are doing the work. Okay, this is the minimum length of the rope pattern required, 10 meters pattern, and here this is the bucket. Okay, and here he took the bucket and it is completely filled with water like this. Okay, this is the bucket he is trying to pull from here to the surface. Okay, neglect the size of the bucket, Nana. Height of the bucket not given, so neglect it. This length he gave 10 meters. Okay, it is 10 meters. Yeah, good. Then here You are pulling the bucket from what depth? First try to understand. You pull the bucket from what depth? Minimum length of the rope 10 meters. Ah, very good. From a depth of 10 meters. Okay. So here, if I take, this is the reference level, means the surface of well. Okay. As the reference level. Yeah, good. Correct only. Now I think the bucket is below the reference level. Below the reference level means, shall I say, potential energy of bucket is equals to negative. That is a silly question, Shrestha. Mass is distributed to the total volume or size. Then where you consider the mass of body? Where you consider? So to say that mass of rope, suppose if I ask, mass of rope is 5 kg. 5 kg, where you take 5 kg, will you take the mass of rope as 5 kg? Will you take the mass here or there or here? Where you assume that 5 kg mass? At the center. Means here the mass you assumed at the center, means at a point. Okay, that point I have to give some name for it or not? Its name is center of mass. Oh, total mass is at center of mass. Okay, total 5 kg is here. Total 5 kg is here means now I can say from the reference level, the mass of rope is at what depth? I can easily say. If I know the depth, I can say the potential energy. That's why we have to consider the center of mass for extended bodies. Extended bodies means the mass is distributed to its size. Now you understood, Shrestha? Yeah, good. That's why we have to assume. If it is a point mass, no need to consider. Tanisha, maybe Nana. Okay, I have to check it, your answer. Okay. Previously, who posted this one? Tanisha. Okay, okay. Previously, you only posted. Right, good. 9.8 or 10, that is your wish. Okay. So potential energy of first bucket, if I take, that is negative. Yeah, mgh I have to write. That is equals to here minus mass of bucket. How much given, Anna? 2 kg. That is 2 g. Okay, I take it as 10. And h is equals to, this time better I write here, g is equals to 10 meter per second square. No confusion. And depth of it is 10. So previously I got minus 200 joules nano. This is potential energy of bucket. Right, good. And it is not massless rope. It has some mass. Just know what we discussed. Its mass already all of you told here for 10 meters length. Yeah, 5 kg. Very good, very good. Mass of rope is equals to 0.5 kg per meter into total length is 10 meters. That is equals to 5 kg. It is at center of mass for Shrestha. Just now I explained. Okay. At center of mass means from the reference level. It is at what depth, Nana? The center of mass is at what depth? Is it at 10 meters depth? Yeah, 5 meters depth. Correct. Good. This is at a depth of 5 meters. So the potential energy of rope, if I consider, why? Because while pulling the bucket of water, directly you can't keeping your hand into the well and not directly holding the handle of this bucket. With the rope only you are pulling, means you are pulling the bucket of water along with the rope. Rope is also pulled to the surface. That's why here the potential energy of the rope I have to consider, that is equals to, using again the formula mgh, below the reference level minus, that is equals to minus, mass is 5, g is 10, and height you told it as 5 for the rope. So total I'm taking here, this is minus 5 5s are 25 into 10, I'm getting 250. Yes. How much you posted, Srestha? Previous 450. Correct only, now. Your answer is correct, Tanisha. Good. So here that implies total, right, total initial potential energy. Okay, that equals to U1 is minus 200 plus minus 250. Okay, that is equals to, that implies U1 equals to minus 450 joules. Everything pulled to the reference level. Correct only, Nana. Answer is correct. Lakshmi Satvika, Deepali, correct. U1 is minus 450. Final potential energy. All are brought to the reference level. Reference level. All are on the reference level means final height is 0. Since final height equals to 0. Why? Because all are brought to the reference level. Okay. So final potential energy means, better I represent here with the letter U2. Okay. So U2 equals to 0. Then I think you can understand that implies work done is equals to, all of you know, U2 minus U1. 0 minus of minus 450, that is equals to answer. I think all of you understood, that is 450 joules. Is it correct, Anna? Plus 450 or minus 450? Plus 450. So work done is equals to plus 450. Very good, very good. Okay. So I think majority of the people responded. So I think they understood this type of model. So better we move to another type of model. Center of mass concepts, I think we can solve. Very, very good, Nana. Right, moving to another concept here. Okay. Till to this previous problem, what we did, even though here, suppose a bucket of water is pulled to the reference level. Okay. We consider the mass of the rope, but that rope is inextensible, not expanding, not extending, not elongating. Okay. So inextensible strings till now we took. Okay. Okay, sure, Nana. I'm in the second page only. Okay, sure to see. If you want to note down any point, you can note it. Then you can note them. So here, if you observe in the meanwhile, till now, to the previous example, we took inextensible strings, Nana. Okay. Suppose that a string, like a spring, extends, means elongates, then how to calculate the work done? This is the next model. Okay. That one I am going to here. Work done in elongating a spring. Okay, this is the model I'm going to do here. Okay, for this theory, first I'm writing like this. Okay, first what you are doing, sir? Simple, Nana. I'm just taking a spring here. This is a spring. Okay, and that spring is connected to a wall, side wall, and here the other end of the spring is connected to a block like this here. Okay, this is a block, right? Initially, here it is placed on the floor, and here it is connected to a spring. Neglect the friction between the surfaces in contact. Consider it is a frictionless surface. Okay, and here you consider it is the natural length of the spring. Natural length means not elongated original length. Okay, not elongated, not compressed. Neither elongated nor compressed. It is the natural length of the spring. Let it be L. Okay, that I write here. A spring is connected, okay, to a block when it is at its natural length, means original length. Okay, right, good, leave it. Now what you are doing, sir? Okay, simple. I applied, suppose, some force on it. How, sir? Like this. If I try to pull like this using some force, pull. If I try to pull, what happens? The block tries to move towards right. Why? Because even there is no friction to oppose. But problem is, it is connected to a spring at the other end. Okay, it is not just placed against, it is connected. It is connected means the spring also tries to come along with this block. Means observe the spring is about to elongate there or not, Nana? It will elongate or not? When I pull, surely elongate. Yeah, it elongates. Yes, coming to here. Okay, the spring, when I pull the block, tries to elongate like this. May elongate, suppose to this position. Okay, came to this position. Suppose I should like this. Elongated. Okay, elongate means look at, he gave till here, it is the natural length from there to here. Okay, this is the natural length of the spring. Okay, yeah, this is capital L. From here to there, I say it is the elongation. Will you accept, Nana? From here to there, this part is the elongation. Yes, good. So this is the elongation in the spring. Just I took from here to here. Okay. If that elongation, I consider it as x, elongation x, that I write here. Let the elongation be x in the spring, then what happens? Okay, this is spring, Nana. It has its own property. What is that property, sir? If I leave this block while pulling, suppose pull to here, and simply if I leave it, okay, means if I leave my hand from the block, immediately this block tries to go back to its original position. Okay, in case of spring, Nana, is it not correct? whether it tries to move back or not. Yes or no? Yes, comes to its initial position. That kind of property, actually, we call it as elastic property, Nana. So because of that elastic property, it tries to move back means who is trying to pull it back? You or the spring? Who tries to pull the block backwards? Spring or the person? Ah, very good. Spring. So spring is trying to apply some force here in the backward direction, like this. Okay. This is the force developed in the spring. Okay. That force, here I am writing, the force developed in the spring to restore the original position, to the block some force is developed. That force we are giving some name. The force developed in the spring. Okay. For what purpose? Hey, what happened? Thank God. Here, for what purpose? To restore the original position. To whom? To the block. Okay. Is called restoring force. Okay. Restoring force. That restoring force, let it be some F. Okay. That F mainly depending upon the elongation. Means if you elongate less restoring force will be developed. If you elongate more up to here, the restoring force developed is also more. So are they not related directly? They are related directly proportional or not? Yes. Sorry, Nana. I think we lost all the pages also. Okay. So here, this is the problem with the instability in the network. Okay. See here, no pages are there. So better you take all the pages from YouTube. Okay. I can't provide those pages today. So better I stop it here. Okay. Till I think we took the points from F is directly proportional to X. Correct, Ananda? Suddenly it was stopped, Nana. Okay, that is internet problem. So I lost all the pages suddenly. So better I stop it. I will continue the rest of the part in the next class from where like F is directly proportional to minus X. Okay. Yeah. So you take the pages from YouTube, Nana, there you can find out. Okay, na?